Okay, we're going to evaluate functions, and simply in order to do this here, all I'm going to do is just what I call plug it in, and I'm going to go up here to this problem right here, and what I'm going to basically do is this. Everywhere the x is, I'm going to make parentheses, and I could do that for all three of these problems right here. And what I'm going to do is just this, plug in the numbers that go right there. This particular one was the number 2. This one's 1.5, y plus 2, so I got to put a 2 here, 1.5 and y plus 2. So first off, oops, and what did I forget? You cannot forget this here. I did forget a very important part. I didn't write the problem down exactly right. You have what? Squares on those. Be very careful, it's very easy to forget something. So basically, and there's a difference. The reason I like the parentheses, if you type it in your calculator like this, you will not get it wrong. Because this means take 2 and square it, make it negative. It does not mean take negative 2 times negative 2. That would be positive 4. This is 2 squared, which is 4. Make it negative. So I would have negative 4, and 3 times 2 is 6, and negative 4 plus 6 is 2. Here, I'm going to take the 1.5 and square it, and I believe 1.5 is 2.25, and then make it negative. And 3 times 1.5 is a positive 4.5. So if I take negative 2.5 plus 4.5, I get a positive 2.25. Now this one here, you have to FOIL. You will have y plus 2 times y plus 2. You FOIL the first terms, you end up with a y squared. The outside term makes a plus 2y, plus the inside term makes another y, 2y. And then I have a plus 4 for the last terms, first, outer, inner, last. 2 times 2 is 4. And then I have this plus 3y, and 3 times 2 is 6. Distributive property right there across that. Well, what can I all put together? Oh, wait a minute. And these here are all what? Should be that parentheses. Because I still have what in front of it? A negative. Very easy to forget that. I've almost forgot something twice on this problem. Well, let's do it this way. Here we have a negative. It's y squared, and the 2 y's make 4y plus 4. That negative front is going to make it a negative y squared minus 4y minus 4, and then I still have this what? So I have the 3y plus 6 plus 3y plus 6. I can put this will be negative y squared here. Negative 4y plus 3y makes a negative y, and negative 4 plus 6 makes a positive 2. So the final answer is negative y squared minus y plus 2. Be very careful. Some things I almost forgot, which is what most people do, that these are what? Squared. And I almost forgot the negative sign right there. Those are very, very important, because without each of those, it changes up the answer. Now, I'm going to do the same thing right here, except this one is a piecewise function, which means this. When x, in this particular states it this way, if x is 0 or positive, I use this one. And this means if x is negative, I use the top formula. So let's go here and look at f of 1. This is a negative number, so negative numbers would be less than 0, so I'm going to use the top one for this one. So I'm going to go to this formula, and it will be 2. I'm going to make my parentheses, and I'm going to plug in the number negative 1. Well, 2 times negative 1 is what? Negative 2 minus 1 makes a negative 3 for an answer. Now I'm going to come here to this one. Notice 0. This has to be less than 0, so it's not in the top one. X can be greater than or equal to 0. Well, since it can equal 0, I'm going to use this formula right here on this one. So I'm going to go to the formula, go 2, make my parentheses, plus 2. Only this time I'm going to plug in 0. Well, what's 2 times 0? 0. And 0 plus 2 makes the answer then 2. And let's go back to right here. 2. 2 is definitely greater than 0, so it's not here. So I'm going to use, once again, this function right here. So I'm going to type it in just the same. only this time I'm going to replace, instead of the x, I will replace the number 2. And 2 times 2 is 4. 4 plus 2 makes 6. A piecewise function, the difference between that and this is you're going to use all these in this one formula. Here we have 2 formulas, but it tells us when to use which one. When they're negative, use the top one. When they're 0 or positive, you use the bottom one, which is what we did. The negative ones, we use that one, and this right here. And that sometimes happens in life where there are 2 different things based on what the numbers are. We use different formulas or different criteria.